Okay, so at this point, now we know three different types of problems. So I'm just going to summarize them real quick. You know that a GCF, that could apply to all problems. So you always have to check if there's a GCF. We know a simple ABC. Simple ABC. Simple ABC has three terms. And it also has A equal 1. The third one we know is a grouping problem. Grouping is the easiest one to tell because it's the only one that has four terms. Now what we're going to do today is we're going to take a look at a complex ABC. So the thing about a complex ABC is if you remember ax squared plus bx plus c, it has to do with this, and a is now not equal to 1. So it's any other number besides 1, and that number is also not the GCF. So here's how we do these problems. It's actually just a couple of extra steps. What we're going to do is we're going to take this problem and we're going to convert it into a grouping problem. So right now it has 3 parts to it. We're going to change it so it has 4 parts. Here's what you do. Take the 3 and the 8 and multiply it to make your list. So you make your list 1 and 24, 2 and 12, 3 and 8, 4 and 6. And out of that list, we need to find something that could make 10x. So out of this list, it would be this one. Since everything's positive, it has to be plus 4 and plus 6. So we take 4x and 6x and we replace the 10. Because 4x plus 6x does give you 10. Now I want to briefly mention about this 12 and 2, because that could also make 10, but the only way to make 10 is having a negative, but that's positive. You can't have a negative and get a positive, unless there was 2 negatives, but then you would have a negative 10 in the middle, or actually a negative 14, so that doesn't work. So then we just drop down the front, drop down the back, and now we do these like the examples that we did in the previous lesson. So we're going to group it, factor the GCF out. So this one is just x, and then we take 3x plus 4 on the inside, bring down the plus sign, GCF, so this would be 2. So then we take it out, that's 3x plus 4, and again, this is where you can see that we're doing it right. You got the matching parentheses, so you have 3x plus 4, and then the 2 in the front, they go into their own parentheses, so you have x plus 2. That's your answer. So I'll show you this a couple more times, a couple more examples. So the big thing is, remember, you have to multiply the first and last term. Now on a simple ABC, you can still do that, but the thing is, it just ends up being the last number. Because when you multiply the first and the last, the first one is a 1 on a simple ABC. So it really doesn't have an impact, and that's why we just attack the last number to make our list. So in this one, we have 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Out of that list, we need to make 17. So this is the only one that can make 17. It has to be a negative 17, so there are 2 negatives. So we use that to split up minus 2x and minus 15x. And guys, you have flexibility in this problem. You could switch the order of the 2 and the 15. Doesn't matter which one you put first. In the end, it'll all work out to be the same anyways. So we bring down the first, bring down the last, and now we split the middle. Now the thing to note from the last set of notes is if there's a minus in the middle, we have to adjust this sign right here, because technically it's not the same problem. So now we GCF this up. So we take the x out. So that leaves us with 5x minus 2. And then we have the minus from the middle up here. We bring that down. When we take out the GCF, it's going to be 3. So we put the 3 in front. Then on the inside, we have 5x minus 2. Matching parentheses becomes 5x minus 2. And then the 2 from the front, they go on the inside. X minus 3. Oh, not 33. That's supposed to be a parentheses. There's our answer. Okay, one more. Let's see what we got here. There's no GCF, so I can multiply the first with the last. That's negative 30, which happens to be the same exact list. 1 and 30, 2 and 15, 3 and 10. Oh, 5 and 6. Trying to make 1. The only way we can make 1 is out of 5 and 6. It's got to be a negative 1, so it'd be minus 6 and plus 5. So we use that to replace the the term that's in the middle. So I go like this. And guys, like I said, I have flexibility with this. If I really wanted to, I could put the minus 6x here and the plus 5x, so I don't have to worry about that sign change. Because this sign right here, this is going to be the sign in the middle that we use to split the middle. So if you have the 6 there, you would have a minus in the middle. Matter of fact, I'll leave it like that and I'll do it this way. So what ends up happening is when you split the middle, it just changes what your GCFs end up being. So in this time, if I do it this way, it ends up being 3x. So I have 3x in front, and I have x minus 2 in back. And I bring down that plus sign. I take out the GCF of 5. Sure, I should probably use green on that one. 5. So 5 goes in front. And then on the inside, we have x minus 2. So if I did it the other way, I would have had 3x plus 5 in both parentheses, and then an x in the front of the first one, and a 2 in the front of the second one. In the end, though, it all works out to be the same. You'll have x minus 2, and then 3x plus 5. And again, order doesn't matter. So if the 3x plus 5 came first, x minus 2 goes second, it's the same answer. It'll all FOIL to the same exact thing. Now I want to mention multi-step factoring. So in the first set of notes, we learned about the GCF. Now you should technically always check to see if there's a GCF first. So in this problem, the GCF is going to be 3. So I take out the 3, and I'm going to make this 3 super bold, because I'm actually going to come back to that later. So I need to rewrite the problem. So my problem is going to now be 12x squared minus 11x plus 2. So what we're going to do with that is we're going to now treat this as a complex ABC and multiply the first and the last to make our list. So we got 1 and 24, we have 2 and 12, we have 3 and 8, 4 and 6. Out of that list, there's only one that can make an 11. So to make a negative 11, it would have to be negative 3 and negative 8. So I can take this and I put negative 3x and negative 8x. And then I bring down the first term, I bring down the last term. Now this guy right here, I'm going to leave him for a minute because I don't want it to get all mixed up with the other stuff that we do at this point. So I put the parentheses, I have that minus in the middle, so I have to adjust my sign on the right. Now I can GCF each part. So this is 3x, 3x. The other one is going to be 2. So I have 3x, and I have parentheses of 4x minus 1. Then I have the minus, and then I have 2 in the front. Then in parentheses, I have 4x minus 1. So we end up having 4x minus 1, and then 3x minus 2 in our parentheses. And then we bring this guy back into the very front of our problem. So this would be our final answer. Now if you forget to put the 3, which a lot of people do, it completely changes the problem. You should be able to FOIL this back and end up with 36x squared minus 33x plus 6. So if that 3 is missing, you're going to end up with 12x squared minus 11x plus 2, which is not the same problem. So you've got to remember, if there's a GCF, you got to carry it down into the final part of your answer.